Okay, this is question 2b. Right, part 1 says expand 1 plus 3x to the power of 0.5 as far as the x cubed term. So this is a binomial expansion. It's in the right form of 1 plus something to the power of something. Because it's fractional, we're going to use the actual expansion itself, which is 1 plus nx plus n times n minus 1 over 2 factorial x squared. And because it says x cubed, we need the third one as well. So the third one is n times n minus 1 times n minus 2 all over 3 factorial x cubed. So in this situation, we know that n is 0.5, or a half, and the x is actually 3x, because it's this bit, excuse me, over here. Right, so we're just going to substitute them in. So 1 plus a half times 3x, I'm going to write as 3 over 2x, plus, it's a half, which is n minus 1, or a half take 1 is minus a half, all over 2 factorial, which is 2, x squared means we're doing 3x squared. And for the last one, scroll across a little bit, it's going to be a half times n minus 1, which is minus a half. We're taking away another one from that, so it's minus 3 over 2. All over 3 factorial, which is 3 times 2 times 1, which is 6. And x cubed is 3x cubed. Okay, so let's simplify this a bit. We can't do much with the first two, so I'm going to leave those as 1 plus 3 over 2x. The next bit, we've got a half times minus a half, which is minus a quarter. We're dividing or timesing that by a half as well, so it's going to be a minus an eighth. But then the 3 squared here gives us 9, so it's going to be minus 9 over 8. And that's the x squared term. Then here we've got a half times a half. There's two minuses, so it's a plus, so first of all. The denominators of the top is a half times a half times a half. It's an eighth. On the top you're going to get 3, so it's 3/8 on the top. We're timesing that by a sixth, so you get 3 over, what's the bottom? It's 48. And then on this bit here, the 3 cubed is 27, so we're going to get, what did I say? I said 3 over 48 from the fraction here, positive. Then we're timesing that by 27. So it's going to be 81 over 48. And did it cancel? Yeah, both in 3 times table, so we can divide by 3. We're going to get 27 over 16. So you get the answer of positive 27 over 16, and that's the x cubed term. I think that's all it asks for. Yep. Okay, so that's done. Part I. State the range of values when it's valid. So this isn't valid for all values, it's only valid for values that are in between minus 1 and 1 for the original function. The original function is 1 plus x to the power of n, and this is only valid when x is in between minus 1 and 1. As soon as you go past those limits, there's an exponential change in the accuracy. But in between those two limits, it's a bit like the r value, it becomes convergent. So it's not actually x, remember, we're using 3x. So this now becomes minus 1 to 3x to 1. But it says when's it valued in terms of x, so we can divide both sides by 3, so minus a third and a third. So it's valid between minus a third and a third. Sorry about that, 3 there. Okay, so that's part B. And then part C, a student suggests the following check to determine whether the expansion is obtained in part B1 may be correct. Use your expansion to find an estimate for root 103. So is it similar? So it's got here, we've just done an expansion of 1 plus 3x to the power of 0.5. Well, that could be rewritten as the square root of 1 plus 3x, like that. Okay, so it's similar here. Now, if you think about it, you've got 1 plus 3x, and you want to make it similar to root 103. Now, it looks like you could do like 100 plus 3 here to get 103, so you can see there's some sort of connection between the two. Right, it says compare this with the value, so we have to try and do this. Now we know we're only allowed to use the x values in between minus a third and a third. So let's think about how we're going to do this. We need 1 plus 3x, to be 103 for starters. So 1 plus 3x needs to be 103, and then they match up. So let's make that equation over here. So we're going to get 1 plus 3x is 103. So if I do that, if I take away 1, I'm going to get 3x is 102. Therefore, x would have been 102 over 3. That does divide, so it's 34, I think. So if x was 34, that would work. Problem is x needs to be between minus a third and positive a third, so we can't use 34. It wouldn't be valid. So we have to think of another way of doing this. So if we think about this, 103, we need to think of a way of getting the x to be smaller. Now, if we think of 103 in a different way, so if I think of this as 100 times 1.03, that would work. This and this would be the same. So I know that root 103 is the same as root 100 times root of 1.03, using properties of surds. And that's the same as 10 times root of 1.03. So this and this are the same. So what we can do is we can now look at the expansion for this instead. So we've got the 10, we're now looking at root 1.03. So we want 1 plus 3x to be 1.03, and then it would be the same as the thing underneath the root. So we take away 1 from it, so 3x would equal 0.03. Divide by 3, x would be 0.01. So now we have an answer that we can use because it is in between the limits. So we go back and it says, showing your working, carry out this check on your expansion from part B1, sorry. So we're going to substitute in x is 0.01, and we're going to substitute it into our expansion here. So we're literally going to replace it in here and see what we end up with. It says carry out the check, so 5 decimal places it needs to be correct to. So we need to actually use the calculator to type in root 103, and we need to use the substitution of 0.01 in the expansion earlier to see what we end up with. So as we do that, we're going to get from the substitution, I'll call it here, the substitution, that's going to give us 10.14889. You can check that on your calculators. Let me just see how many decimal places, significant figures. 5 decimal places. 1, 2, 3, 4, 5. The next number's a 1, so that's fine. So that's the substitution. We now need to do from the calculator. If I type it onto my calculator, I get 10.14889, and it goes 1 next. So yes, I would say it agrees. Like that. Okay. That is question 2 done.